I came to Waikato about 5.5 years ago. Before that I spent 8 years at Hewlett-Packard and Agilient Technologies in California. Before that I worked for an RF company in Australia. I taught at Sydney University. Back in the 1980s I had my own electronics company. Before that I was a journalist, so I've had a great deal of experience. When I was an undergraduate in the 1970s, we used to think that if you were a good engineer, when you died and went to heaven, you got to work at Hewlett-Packard. And years later, I did get to work at HP, and when it spun out Agilent, and it was a fabulous experience to be in the innovative culture. It was a family. Someone actually telephoned me when I got there and said, "Welcome to the family, call us if you have any problems." Nobody had ever done that sort of thing for me before. The environment was fantastic. What you learned from that experience was fantastic. And I loved working for the company. I still love the company, even though it's rather different these days. When I was there, I built a small wooden table which sits now at the entrance to my office. It has a small train on it which carries around a little Hewlett-Packard carriage, just as a symbol of the fact that I'd been to heaven. Developments come really in two types. You can break invention into two parts. There's push invention, which is where you have a great idea and you have to convince people that it's an idea it's worth them paying for. And that's really called pushing or push marketing. The reverse is pull marketing, and that's where you've got someone who says, "I have this problem, I really need you to find a solution," and so you start looking for a solution in that direction. Of course, it's vastly easier to get your invention commercialized if you've already got a customer in the pull situation. That usually happens when a company gets connected to a researcher. And Waikato Link is as good at doing that as it is the reverse. So if you have a brilliant idea, they look for someone who can use that idea in their particular marketing area. The reverse is where there's a company and that company has to find the right researcher, the person who's got the skills and the knowledge and the experience to solve their problem. And that's a question of having the connections, having someone between the companies and the academics who knows enough people to recognise when it makes sense to make a connection. Both of those are important. So certainly if you're looking for a field of research and you want to have a chance that that will go out into commercialization rather than simply get published in a journal, then you have to start by looking for the people in industry who've got the problems you might be able to solve. And for doing that, I guess you can tramp from door to door, or you can turn up to find someone who does that tramping from door to door for you. Waikato Link at Waikato University is there to do that kind of thing. So if you say, I'm in this field, tell me the companies who are operate in that sphere, give me some of the problems, and it's always fairly easy to commercialize in that direction, but you've got to find a company who wants to do the kind of things you want to do. So you've got to find an industrial connection who's in your line, or you wind up working on something which you feel as if you ought to be paid for, and that's no good. That's not what a university should. That's not the game you should be in. You've got to enjoy what you're doing. You've got to want to see it go out. You've got to have some enthusiasm behind it, and so you need to find the right company who's going to have the same enthusiasm for the same invention. I often give my students something like a startup book to read. Most students want to run a company or start a company. A spin out is the golden aim, and some of them do actually. But there is certainly a point where research at a university wants to move out to a company. There's various things which we've progressed to the point where we get local companies involved in the production of something. When we want more than about 3 of them, it's time to find a company. You either spin out a company and start manufacturing them if you think there's enough of a market. Maybe you go to local companies and you get them to assemble something for you. We have various projects at various points where we get local companies involved. As I said, sometimes my students have started up, there's a couple of groups who've started up companies when they left. Those companies, you know, like my first company, don't tend to fare all that well because you find there isn't enough market, but there's a pathway to come out of a university into commercialisation. Our students are always enthusiastic about doing that. The place is pretty good about that. You have to deal with intellectual property, you have to handle it sensibly, protect it where you can, run with it in other circumstances. That's something this place does very well. It's small, it's integrated with the different departments, it's close with local manufacturers. It's a good environment for that. To get effective research done, you really need to have a critical mass. It's much more difficult if you're working by yourself. You know, working by yourself is more like a consultancy job. It's less fun. You want to be paid. But if you want to get some real momentum in a group where ideas are being bounced around and put out into the field, you want to collect students. And I discovered almost by accident that the ingredients to attract students, and now I have to refuse most of them who come to my door because I have more students wanting to work with me than I have capacity to handle. The first thing is you have to pitch the idea or the project with some enthusiasm, and you have to tell them it's going to be fun. You don't want to do a year or 3 years on something that's dead boring. So you've got to pitch it excitingly. And I discovered also that it's very effective to put it on a web page. I think they like to go back and read it a couple of times. They don't want to feel as if you're giving them a hard sell. But you say, oh, if you're interested in this field, I have 2 or 3 projects. Here are the URLs. Feel free to read up on them. Come back, talk to me afterwards. That's worked a charm for me. An important part of commercialising something comes from you really wanting to see your baby out there. You know, I get students who will come to me and they say, yeah, I really want to work on something that's going to be patentable and make a lot of money. And you actually don't want to take those students on because they're just, you know, it's a business exercise and they're not there's no love of the technology. It has to start with the love of the technology. That's what Bill Hewlett loved what he did, and his ideas were loved by other people. He wasn't sitting there thinking, I'm going to make a multinational company out of this. He said, you know, if we've got something that's useful to people and it sells well, that's great. And that attitude is very, very important to something being seen through the distance. It's a long distance. You've got to love doing it, or you don't get from the start to the end. The tampered sensor came out of the fact that I was attached to a club, and the club rooms would get vandalised. And it reminded me of my favourite statue, which was in a park near where I lived in Sydney many years ago. And it kept getting vandalised, and the council would continuously repair this piece of sculpture. But eventually they got sick of doing that, and my favourite bit of sculpture disappeared. And the older people may remember when car burglar alarms first became a popular idea. You'd get a thunderstorm or a loud noise and all sorts of car burglar alarms everywhere would go off. And they often went off when the car wasn't being stolen, with the result that nowadays when a car burglar alarm goes off, people hardly raise an eyebrow. And I thought to myself, gee, I wish I had some way of protecting monuments, heritage listed buildings, that kind of thing, where people would pay attention to the alarm. They wouldn't assume it was a false alarm. And so, you know, we thought that would make a very fine student project. And we'd had some equipment that was ideal for the job. It was serendipity. The idea came together and it worked superbly well. I mean, we just couldn't believe how well it worked. We had competitions where we invited people to set this thing off by firing shotguns, you know, jumping up and down next to it, and we couldn't give away $1,000 for anybody who could set it off accidentally. So we knew it really worked superbly well, and that's where the product came from. it works using something you may have seen on old westerns. If you've seen one of these western movies where the Indian sticks his ear on the railway track and he can hear a train coming from a huge distance away, and the idea is that the sound travels far better in the track than it does in the air, and we're using exactly the same principle. So the thing is listening both to the environment, but also it's got its ear pressed against the thing it's trying to protect, and it knows that if there's a tremendous ruckus in the air, that a small amount of sound in the thing it's trying to protect is not a problem. But if it's a quiet evening and there's some serious noise attached to the object, then it probably means there's somebody with a crowbar trying to pry it open or break it off or whatever. And so using that same technology, it's doing an electronic version of the same thing with a tiny computer embedded the sensor, and it comes out that it's extremely cheap. It's very versatile. You can use it to protect the wrought iron grills on buildings. You could use it to protect statues. You can attach it to heritage buildings. I believe there's people thinking of using it to attach to a boat, on the theory that when someone actually steps on the boat, it's like the train coming down the rails. You can hear them coming. The smart sprinkler is something that's halfway between push and pull marketing. You've been able to get automatic irrigation systems for years. Farmers use them. They assess the rain, the temperature, all the environmental conditions, and they can adjust the amount of watering you do on your crops, and that's fantastic because it saves a lot of money. It doesn't water when you don't need it. It waters more if the weather conditions become extreme. You can also buy tap timers like this thing here, and they're designed for domestic use. You thread them on your garden tap, and you put your hose on the bottom, and you put a battery in it, and you dial up some sort of setting on it, and it waters your home vegetable patch or whatever. And you know, they're a fantastic device domestically. They have the advantage they don't need any maintenance. They will sit there doing that happily for a year. And that can be water wasteful. And we know that in certain places, particularly the eastern coast of Australia and California in the US, are thinking of banning the sale of automatic irrigation devices which don't take conditions into account. And it occurred to us that we could build some smarts into these devices so that they measured the sunlight and the temperature, and they can do that very robustly. They won't need any maintenance. There's no probes running into the ground, no wires to rust, nothing that fills up with water accidentally. And once you've built the smarts in, because you can buy a small computer these days for less than $1, you could put that smarts into one of these things and you would not be increasing the price by more than $1 or $2. And so we've built this gadget, and we've done quite a bit of work and published it and mentioned it to Waikato Link because we think this is a great idea. My personal belief is that it isn't going to sell until legislation demands that it happen, because the companies are happily selling the dumb sprinklers, so they don't have a whole lot of incentive to make them smart. But if that legislation comes in, we're certainly going to be ready, because we've spent a lot of time debugging and perfecting this gadget. One of the projects which came to be an instrument that Agilient is selling was a project that I was told not to do 3 times. And we really knew that what we were working on was going to be useful. And it turns out, if you read the literature, that an enormous fraction of the successful projects coming out of Silicon Valley were what were called skunk works, which was something done under the table, unofficially, an idea cooked up behind people's backs or without proper funding. So it's almost as if the staff were siphoning resources off into something they shouldn't have been doing. And you know, in about 25% of the time, it turns out that it really was something you should have been doing, and it makes a bundle of money in the end. I worked on a pulse generator, a phase reference, which is now sold as a product, and it's a key element inside a nonlinear vector network analyzer. So there's a lot in developing an idea to commercialization which doesn't match the prevailing policy. It's something which the marketing department wouldn't have approved because nobody really knew they were going to use it. It was just a gut feeling on the part of some of the engineers involved that that was a really cool idea, and we can't let that drop. It's too good, too elegant, too useful, and it really does turn out to be useful when you've finished. So there's a lot of pursuing that, and you're very lucky if that gets to market. You will often produce something that's beautiful but doesn't sell in a big way. The examples of Skunk works that people have loved but they nearly lost their shirt over. But it was still an extremely good piece of engineering. It's just something that failed to cross the chasm to commercialization. You know, there's all sorts of things that I invent that I think that's terribly neat, and a couple of people will say, we saw you did that work, it's wonderful, but I'm never going to make money out of it because there's just not enough people who want to do that to make it worthwhile. You know, like you could invent a parachute for a motorbike, but you know, not enough motorbikes need parachutes. It's never going to fly. It might be a brilliant parachute. Good students, good graduates arise when you have good teaching and when you have student engagement, and bearing in mind that I think engineering should be fun, we try to get as much fun and enthusiasm in to engage the students. As an example, we have a final year program on mechatronics. We teach the students to execute data communications projects. We have them talk to digital model trains and they drive around a track. We've also started playing with digital slot cars. If you haven't seen these things before, they work like ordinary slot cars, except you have lane changes so you can overtake your competitors. And we have a project to get a computer to drive the slot car better than a human can. And the slot cars are a remarkably good model of real cars, except for the steering part. Round we go. Come back, come back. There you go. Whoa. And we'll see if we can land him. Oh, oh, oh. Whoa. Close. Even tells you when you're crashing. You know, gives you a picture of what you're doing on your latest PDA. Isn't technology marvellous?
We can weld together large structures. We provide all of the students with access to lathes, milling machines, tools. We have small workshops up in electrical engineering where the students can go and do work quickly. That's a big plus on a department. You don't spend time waiting for things, you can get hands-on right away.